Hello, everyone. In the die-casting workshop of an automobile manufacturing plant, a robotic arm can complete a precise component handling operation every 53 seconds. However, if the trajectory setting error exceeds 1 millimeter, it can result in the damage of molds worth millions. In the field of industrial robotics, setting handling trajectories is not merely a technical operation. It is also a concentrated embodiment of scientific thinking and an exploratory spirit. Have you ever wondered why the same robot can have highly efficient and precise trajectories when programmed by some engineers, while others frequently make errors? The difference lies not only in technical skills, but also in scientific thinking and the spirit of exploration. In this lesson, let us delve into the topic of setting handling trajectories and simulation programming and uncover its underlying principles. In this session, we will focus on the following two aspects. Learning objectives. Mastering the methods for setting handling trajectories in a simulation environment, including the precise configuration of starting points, approach points, pickup points, and placement points. Independently completing simulation programming, including program creation, logical configuration, and error debugging to ensure error-free simulation execution. Before starting the task, let's examine a case study. An engineer at an automobile manufacturing plant found that the traditional method of setting robotic handling trajectories was inefficient and prone to collisions. Instead of sticking to conventional methods, he applied scientific thinking, conducted repeated experiments and data analysis, and ultimately designed an optimal trajectory that improved handling efficiency by 30%. This engineer's story illustrates that scientific thinking and the spirit of exploration are the keys to solving engineering problems. Now, let's move on to task 3, setting handling trajectories and simulation programming. Step 1. Configuring simulation rules. We need to pick up the motor end cover from Handling Module 1 and place it into Handling Module 2. In the left side menu under the Fixtures directory, locate Handling Module 1, right-click, select Properties, navigate to the Simulation tab, and uncheck the box before Allow Part to be placed. Click Apply. For Handling Module 2, perform the opposite operation by unchecking Allow Part to be picked and clicking Apply. Step 2. Simulation Programming. In the left side menu, find Program, right-click, and select Add Simulation Program. The program name must not start with a digit. If no modification is needed, click OK directly. Once created, a programming window will pop up, which serves as the code editor. Step 3. Resetting the robot to the home position. In the top menu bar, locate Lock/Unlock Teach to Selection. Click on it, and select Joint Mode in the lower status bar. Modify J5 axis to -90 degrees and press Enter on the keyboard. Thus, the robot has reached its home position, and we will record this point as the first point. Record this as P1 by selecting the triangle button next to record. Step 4. Moving to the approach and pickup points. To reach the approach point above the pickup location, in the left side Fixtures directory, find Handling Module 1, right-click, select Properties, go to the Parts tab, and click Move to. The robot will move directly to the motor end cover position in Handling Module 1. Then select the record and record this point as P2. Since P2 is the pickup point, we need to create an approach point above it by modifying the coordinates of P2. Record the new position as P3, which will serve as the pickup point. Step 5. Executing the pickup action. Expand the Insert drop-down menu and select Pickup. Configure its logic by setting the pickup option to motor in cover. The system will automatically retrieve the predefined settings from Handling Module 1. After completing the pickup action, we need to return to the upper point. To do so, we can repeat the same operation, moving 50 mm upwards in the Z direction. Once reaching the upper point, the final step is to return to the home position, which can be quickly achieved using the previous method to record the home point again. Step 6. Placing the motor in cover into Handling Module 2. Click Handling Module 2 and select Move to. Record the working point. After completing the recording of the working point, we need to add the action of drop. Expand the Insert drop-down menu and select Drop. Setting the drop option to motor in cover. The system will retrieve settings from Handling Module 2. After placing the object, move back to the approach point. And finally return to the home position. At this stage, we have successfully completed the handling trajectory setup for the simulation. Step 7. Running the simulation. Click the Run panel option. Select the program to simulate and click Run. During the test run, we noticed that even before placement, Handling Module 2 already contains a workpiece. This indicates an incorrect simulation visibility setting. To correct this, open Properties in Handling Module 2. Navigate to the Parts tab. Uncheck Visible at Runtime and click Apply. Run the simulation again. This time, at the beginning of the operation, Handling Module 2 will no longer contain the motor end cover. Then, this completes task 3. Through today's lesson, we not only learned how to set up handling trajectories but also practiced simulation programming. We mastered the entire process, from configuring simulation rules and resetting the robot's origin position, including the precise configuration of starting points, approach points, pickup points, and placement points, as well as creating simulation programming, including program creation, logical configuration, and error debugging. By mastering these skills, you will be able to apply them in real-world scenarios, continuously refining your scientific thinking and exploratory abilities. This will enable you to contribute to advancements in the field of industrial robotics. That concludes today's lesson. Thank you, everyone.